Hello students, welcome back to the Tantra physics classes. Today we are discussing a new concept, that is inertial frame of reference, non-inertial frame of reference, and with that is related pseudo forces. And these three things I will discuss with you. And these lectures will be available on YouTube and also on my channel, on my app, that is Tantra physics class. Okay, three things I am going to discuss with you. Inertial frame of reference. Inertial frame of reference. First of all, I will explain this. Inertial frame of reference. Inertial frame of reference can be a coordinate system. It may be a person who observes the objects, who analyzes the motion of the object. And there's an object, you want to analyze its motion. You have to look at the object from certain frame, from certain position, from certain reference point. The question is, what is that reference point? Who is that observer who watched the object? Is that observer at rest, or is it moving with constant velocity, or is the observer accelerating? And interestingly, the observer who is at rest or who moves or who accelerates analyzes the object differently. He analyzes the object differently. He watched the object differently. So, what is this inertial frame of reference? I will call it the nice good frame of reference, from where you can watch the object, you can observe the object on which there are forces, and you can analyze its motion. Inertial frame of reference is a coordinate system which is either at rest or it moves with a constant velocity, or it moves with a constant velocity for some other person who is at rest. And the person in this frame of reference, when he analyzes the object, for him analysis is simple because he uses Newton's laws. He can directly use the Newton's laws to analyze the object. He can directly use the Newton's laws to find the motion of the object, its velocity, its position, its displacement covered. Everything he will analyze using Newton's laws of motion. So, inertial frame of reference is a coordinate system which is either at rest or moves with constant velocity. That is all. Rest and constant velocity is equivalent in physics. There is no difference between rest and constant velocity. Constant velocity, velocity is equal to 0 and continues to be 0, and constant velocity means it has some velocity but that remains constant. Rest and constant velocity is absolutely the same in physics. Okay, now let me write inertial frame of reference is a coordinate system, which is either at rest or moves with constant velocity. Something like this: x, y, maybe it is z axis here. The velocity is either 0 or velocity is constant. And here is the observer in this. It is the observer in this frame. It's a coordinate system. Either this coordinate system is at rest or it moves with a constant velocity. And there's an observer in this coordinate system which is either at rest or moves with the coordinate system with the velocity, constant velocity. What is good about this coordinate system? When this person observes an object outside, he will use Newton's laws directly. So Newton's laws are valid in the inertial frame of reference. We have to write that. Newton's laws of physics Newton's laws of physics are valid in such a frame of reference. That is, he can directly use the Newton's laws. Newton's laws, F is equal to ma. If a body has a constant mass, he can use F is equal to ma. All the force acting on the object is equal to mass of the object and its acceleration. What is non-inertial frame of reference? Non-inertial frame of reference. Opposite of this. Non-inertial frame of reference. Non-inertial frame of reference. Inertial frame of reference. Non-inertial frame of reference. It's a coordinate system here. And this coordinate system moves with acceleration a0, let me suppose. And obviously when it is accelerating, its velocity is not constant. It is accelerating, obviously. It's a person here who is in the frame and is also accelerating with the frame. It's a person in the frame of reference or in some system, maybe this is a bus or it's a car accelerating, and the person is inside the car. And it is accelerating obviously for this person, and this person velocity is 0. Acceleration of this frame is with respect to this person at rest, ground at rest. The inertial frame was also its velocity was something with respect to person at rest. Otherwise, it is always a relative velocity. We can't say the frame of rest is moving with a constant velocity unless we refer a person who is at rest with respect to whom this coordinate system is moving with constant velocity. And this coordinate system is accelerating in the forward direction. Obviously, the velocity is not constant and the system is accelerating. Okay, now what about this frame of reference? So, non-inertial frame of reference is one whose velocity is not constant and therefore which is accelerating. An accelerated frame of reference is called non-inertial frame of reference. An accelerated frame of reference is called non-inertial frame of reference. What is good or bad about this frame of reference? When the person is there in this frame of reference, when he watches the object outside, somewhere outside this frame, or maybe that object is even within this frame, he will not use Newton's law directly. So Newton's laws as such directly are not applicable. He has to make some corrections. He has to modify the Newton's equation to the object. He will not use Newton's, presently I should say, he will not use Newton's laws directly. So Newton's laws as such in their present form are not valid in such a frame of reference. So Newton's laws of motion cannot be directly used by an observer in such a frame of reference. a frame of reference. So simple. So what is important is that if you are in a system, you are in a bus, and the bus is accelerating, you are inside the bus, and you see some object outside, and you want to apply, you want to find it, you want to make an analysis of its motion. Newton's laws you can't use directly. So that is bad about this frame of reference. So he corrects, I should not say corrects, he modifies the Newton's laws and applies them only after modification. Because in such a frame of reference, he observes something unusual. So let us discuss that. Okay, this has to be remembered. Earth as such is not an inertial frame of reference, because Earth is rotating and is also accelerating around the towards the sun. It is revolving around the sun. There is one acceleration towards the sun. It is also rotating about its own axis. There is one more acceleration. So Newton, this Earth as such cannot be considered as absolutely inertial frame of reference. But for a small time, it can be treated as an inertial frame of reference. But for a short time, its acceleration may not be that it may not be that effective. It may not affect our equations and calculations. Anyway, so now let me observe an object outside from two frames of reference, inertial and non-inertial, and that will also get us to pseudo forces. Pseudo force, PSEUDO, pseudo forces. Okay, this is this frame of reference, coordinate system, is at rest or it moves with a constant velocity. Constant velocity. For a person here, VZ ground, its velocity is 0. So this person says that this coordinate system is either at rest or it moves with a constant velocity, right? There is one more coordinate system, that is this coordinate system. I want to make it like this to compare the two coordinate systems and to compare their analysis on the object. Finally, I have to take the object there. When I take the object there, then these two persons, one here and one here, they will analyze the object so that you understand what are his equations, what he will do, and what this person is going to do. That's very important, right? And now this is x, this is y, this is another coordinate system, and this coordinate system is accelerating with acceleration this. So it is inertial frame. It is inertial frame of reference. Inertial frame. And this is non-inertial frame of reference. Non-inertial. And now both of them are observing this object. That object I will make here. That object I will make here. This object. And on this object there is a force F and mass is M. And this force, this is a real force. What do we mean by real force? A real force is caused by a real agent. I mean, if I push somebody, it's a real force. Gravitation accelerates an object downwards, a real force. Frictional force, these are all real forces which cause real acceleration in an object. Force is created on an object, net force, and the object will get accelerated. That's what we all know. Net force is there, it will cause an acceleration. But this net force, we observe, these forces are created by real agents like gravitation, frictional force, electrical force, magnetic force. For a force, there must be a real agent. So this is a real force. It may be electrical force, it may be magnetic force, it may be a gravitational force, it may be frictional force, which causes acceleration in mass, having mass, the object in having mass M. Okay. Now, let this inertial frame of reference, the person in this inertial frame of reference, let him write the equation for this object. Let him write the equation. What he will write, he will say that there's a real force F. When he says there's a real force F, so he will write F, real force, is equal to mass into acceleration of the object. This person will write this equation. F is equal to ma, F are the forces, is equal to mass of the object into acceleration of the object. He will find this real force. He will add up the real force. Suppose the real force is only 1 and he will write F is equal to ma. Now, if I ask this person, what is its acceleration? He will say acceleration is equal to F by m. Its acceleration is F by m. As always, we do this because we always use Newton's laws, and we always suppose ourselves to be observing the object from an inertial frame of reference. This is what we already know, possibly unconsciously, and we know this because we have been doing it. We measure the real force on an object, find their resultant, then we write that resultant force equal to ma and find the acceleration. Right? Okay. Now, let me ask this observer in the non-inertial frame of reference. Let me ask him, what is the acceleration of this? First of all, I ask him, what is the force on this? He says, force is F. No. He will not say force is F. He says force is F prime. Different. So how much is that force observed by this? He says there is force F prime equal to F real force minus ma0. Because he is accelerating with acceleration a0, he feels there is additional force on this object in addition to the real force. He agrees with the real force. He says there is a real force, but in addition to real force, there is one more force, that is ma0. This is what he feels. This is what he observes and feels about this object. But this ma0 force does not have a real agent. It has no real source. It is not being, this force which he observes does not have a real agent. But he observes this much of force. Where from this force comes? It is because of his frame of reference, non-inertial frame of reference. He is in the non-inertial frame of reference, and he feels there is an additional force on an object. In addition to the real force, he feels there is an additional force on the object opposite to his acceleration, minus ma0. And I ask him, what is the acceleration? He will write F ma prime is equal to F minus ma0. That is, acceleration a is equal to F minus ma0 divided by m. This is the acceleration observed by him, not this. So he will feel a different acceleration on the object. He will say object has a different acceleration, this much, and he will say object has this acceleration. Both are right in their own frames of reference. So what is this force? This has no real agent. This force has no real agent. ma0 with a negative sign. This force is opposite. He feels force on the object opposite to his own acceleration. That is, force on this is opposite to this, that is this way. This way, opposite way. How much? Minus ma0. For him, not for him. So, this is called pseudo force. Because this force does not have a real agent. This force is not caused by a real agent. This force is a consequence of the accelerated frame of reference. So what I want to make you understand, when you are in a system which is accelerating, you will always feel a force on the object outside or within the system in the opposite direction, opposite to your acceleration. How much? Mass of that object multiplied your acceleration ma0, but that force will be opposite to your acceleration. Suppose your acceleration this way, the force on the object will be opposite way, opposite direction. How much? His mass of that object, and your acceleration multiplied 2. That's all. So this is all about pseudo force. Both are correct in their own frames of reference. There's no problem. Both will get the same answer, of course, to the problems that we want to solve. If we solve the problem from the inertial frame of reference, we'll get the same answer. If we want to solve the problem from the non-inertial frame of reference, we will get the same answer. Okay. Now, with this, I end my lecture. But don't forget to download the my app, that is the physics classes. There's a whole lot of literature and questions and videos that I have uploaded there. And also subscribe to my channel, Tantray Physics Class. Okay, thank you.